Good morning. My name is Vishnuvardhan. My roll number is 21951 capital H0246. I am from Tribuli and my topic is about complex matrix inversion. So contents: abstract, introduction, development, algorithm, example, conclusion, and end. Abstract. In this note, a method is presented for inverting a n-on-n matrix M with complex elements. The approach consists in inverting a 2n into 2n matrix with only real elements. Given a complex square matrix M is equal to A plus I into B, its inverse is also a complex square matrix Z is equal to X plus I into Y, where A comma B and X comma Y are all real matrices. It is found that M power of minus 1 is equal to Z, or a plus I into B power of minus 1 is equal to A plus B into A power minus 1 into B whole power minus 1 minus IA minus 1 into B into A plus BA minus 1 into B whole power of minus A. Introduction. A standard technique for diagonalizing a matrix T is to form M1Tm, where M is matrix of the eigenvectors of T. If T has complex eigenvalues, then the matrix M is also will also be complex. In this case, diagonalization requires inversion of complex matrix M. Methods for inverting complex matrix fall into two major classes: direct inversion, identities. Direct inversion, direct manipulations of complex elements in M to form M1. Identities exist which give M1 if M is equal to A plus J into B, where A comma B are real n into n matrices. Then one such identity is due to a relationship attribute forbidden and sure. Development. Direct inversion of a complex matrix requires the ability to perform complex arithmetics. In those cases where complex operations can be declared on the computer, direct inversion is a relatively straightforward procedure. The matrix identity is one of these techniques. It separates the complex matrix M into the sum of two real matrices A and B, then form as M1. Thus, this algorithm for obtaining M1 requires calculating in successions the following real matrices: A1, A1 into B, A plus BA. However, this identity suffers from these severe restrictions that A1 can only be calculated if A and A plus BA minus B exist. For example, consider the following complex matrix M. M is equal to 1, 0, 0, J is equal to 1, 0, 0, 0 plus J into 0, 0, 0, 1 is equal to A plus JB. Neither A nor B, neither A plus BA minus 1B are invertible, and yet it is easy to verify that M minus 1 is equal to 1, 0, 0 minus 1. The three-step development below is based on the isomerism that exists between the field of complex numbers and a special set of 2 into 2 matrix, that is A plus J into B. Is equal to AB minus BA. By definition, the matrix M is A plus J into B is invertible if and only if there exists a matrix E plus J into F such that AE minus BF is equal to I is equal to identity matrix. AF plus BI is equal to 0 matrix, where A, B, E, F are n into n real matrices. Now consider the 2n into 2n real matrices. G is equal to A, B minus B, A. H is equal to E, F minus F, E. By definition, the matrix H is the inversion of G if and only if AE minus BE equal to identity matrix AF plus BE equal to 0. Combining statement 1 and 2 leads directly to the following lemma. The n into n complex matrix M is invertible if and only if the 2 and 2 matrix G is invertible. So algorithms. The development above leads to the following algorithm. Separate the complex matrix M into A plus JB. Form the 2n into 2n matrix G. Invert G by a standard matrix inversion algorithm. Identify the n into n submatrix E and F of G dash with the real and imaginary parts of M minus 1. Example. Let's see the example of complex matrix inversion. The algorithm is illustrated with the sample example as used above. The steps of the algorithms are labeled. Step 1, M is equal to 100J is equal to 1000 plus J into 0001. Step 2, G is equal to 1000 0001 0 minus 00. Step 3, G minus I is equal to 1000 minus 1 0001 0 Step 4, M1 is equal to E plus J of F is equal to 1000 plus J into J 000 minus 1 is equal to 100 minus 1. Conclusion. The algorithms present inverted any non-singular Mn complex matrix by inverting a single 2n into 2n real matrix. Since many computers generally have a real matrix inversion routine but not complex arithmetic in their mathematical packages, this method possesses a significant advantage over direct inversion in the many cases because its roots lie in a mathematical isomerism. This method also removes the idiosyncrasies present in the mathematical identity, which is based on the technique of matrix part partitioning. Let's see what we have learned today. We have learned about abstract, introduction, development, algorithms with an example. Abstract. This is inverting a 2 into 2 matrix. This is introduction about what is matrix and what is complex matrix, inversion and identities, and it is the development, and it is algorithms how to form uh, complex matrix inversion, and this is with an example. Thank you.